Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. So today we are going to discuss an important topic, that is mesitoic acid system. It's a very interesting, so I believe it could be important for your exam. Okay, so actually what is mesitoic acid? So this system is actually, this molecule is actually mesitoic acid, and this is a simple benzoic acid. So why this benzoic acid example I have selected? Because we all are quite familiar with this benzoic acid and its reactivity. So if we compare this, we can understand how much special this mesitoic acid is. Okay, so by the way, one important information, let me give you the pKa value. The pKa of benzoic acid is 4.202, whereas mesitoic acid is 3.448. A simple question comes, why? Because we can see that there are methyl group, 3 methyl group better to say, attached to benzene nucleus, and we know these methyl groups have plus I effect. What do mean? That it releases electron. It releases or pushes electron. So if it pushes electron to the benzene nucleus, it is expected that this 2 4 6 trimethyl benzoic acid, that means this mesitoic acid should be less acidic, so its pK is expected to be higher than this 4.202, but it is not. Why? Interesting property, that is steric inhibition of delocalization. This is a very interesting topic, steric inhibition of electron delocalization. What do I mean? Okay, see, in this case, because of this methyl group, this carboxylic acid cannot remain in plane. What do I mean by that? See, there are 3 methyl groups attached to, actually better to say, this 2 orthomethyl group is responsible. This is not. Why? But why we are discussing this mesitoic acid system? Because its core compound, that is mesitylene, means 1,3,5 trimethyl benzene, is easy to prepare, and any reaction on mesitylene is further easier. Okay, because 3 positions, these and these are symmetrical. Now, so what's actually happening? See, in this case, because of this orthomethyl, this carboxylic acid remains out of plane, either top or bottom, but out of plane. Okay, this. So we know phenyl group has 2 effects. One is minus I, another is plus R, and generally plus R dominates over the minus I. But when there is no chance, or it is not possible for plus R effect to show, then obviously minus I will show its effect, and actually happens exactly this thing for this nucleus. Because of out of planarity and not in conjugation with this phenyl group, the plus R is absent here, only minus I shows. That is the reason, although in case of benzene, see, this carboxyl group is actually in plane with this pi cloud. Consequently, this cloud could be donated somewhat to this carbonyl carbon, which reduces the electron deficiency of this carbonyl compound, this carbonyl carbon, resulting into relatively lesser acidity as well as higher pKa value compared to this one. Okay, so this is the basic thing. A lot of other chemistry we will learn in some next slide. Okay, so see, so first of all, so since we have discussed the property of acid, let's discuss its derivative. For example, hydrolysis of ester. So what do we are going to discuss? See, in this case, this is actually a benzoate ester, this is a mesitoate ester. Better to say it's a methyl ester of benzoic acid, and it's a methyl ester of mesitoic acid. See, methyl ester of benzoic acid under aqueous HCl reflux undergo hydrolysis to produce this benzoic acid and corresponding alcohol, that is methanol. Whereas if you reflux this with aqueous HCl, no reaction occurs. Okay, so question is why? Actually this is relatively easier. Why? How? See, in this case first protonation occurs, then nucleophilic attack. Let me draw something. First of all, the protonation occurs where, see, protonation on this carbonyl carbon, then the water molecule attacks this. In this way intermediate is produced, that is this is OH, one is OMe, another is OH2 having a formal positive on oxygen. Okay, so this, now these undergo further elimination of this methanol by some steps and ultimately produces this carboxylic acid. But that kind of attack in case of mesitoic acid system is not possible. Okay, what do I mean? That if you replace this thing by 3-methyl, then this attack doesn't possible. We will discuss slowly. Okay, so let's go to the second example. Sorry. See, in this case, this is also a methyl ester, this is also a methyl ester, but when you dissolve this in cold concentrated sulfuric acid and the solution poured in ice water, almost no reaction. Okay, better to say almost no reaction, the ester remains in the medium. Whereas, if you do this thing for this mesitoic derivative, means same, then mesitoic acid results. Now, obviously a question comes. Previously that was aqueous HCl, so nucleophilic first protonation, second nucleophilic attack possible. But in this case nucleophilic attack not possible, which I showed. But in the under this condition, since nucleophilic attack is not possible, I mean by this, consequently it produces some special unique intermediate which undergo this reaction. Okay, so this is the beauty of this system. Why? Because in exam it could be asked what is the uniqueness of this system. So I believe it will be helpful. Sorry. So this is the mesitoic acid. So this is the second hydrolysis. Okay. So in order to understand the details, let's discuss the mechanism fast. So what happened? We know that if you take a carboxylic acid and this anything, this, and if you put acid, what is expected? We know that this oxygen is more electron rich compared to this one. Okay, so because this lone pair is in conjugation like this, so consequently this oxygen is more electron rich, so protonation is expected to occur on this oxygen. Okay, so what should be the consequence? This is the OR, this, and this is resonance stabilized. Okay, so now actually in this case this doesn't happen. Why? Okay, let me draw the resonance structure such that it could be little easier for you to, this is the formal positive charge. Okay, now question, this is not possible, so this pathway could not be followed in this case. Why? Because this is okay, fine, it will means this structure, what do I mean, that this is possible, fine, but no benefit, as nucleophilic attack in this case of mesitoic acid system is difficult. Why? See, this is actually a carbonyl group and I told that it prefers to remain out of plane arrangement, means better to say this one. Okay, so this one prefers to remain out of plane. So if it is out of plane, it is not in conjugation, and actually what happens, one part goes beyond, for example this below, and another goes up. So consequently nucleophilic attack, which generally prefers around 107 degree angle, that is Bargy-Dunich trajectory, is hindered because of the presence of these two orthomethyl group. Okay, so because either it will attack from this side or this side, but that may not possible because these methyl groups are there which repel the nucleophile. So not possible. But when we poured this thing in case of concentrated sulfuric acid, reaction happened. Question how? So first of all, most means it is highly expected that protonation will occur here, but it doesn't mean that other oxygen protonation cannot occur. In equilibrium mixture, based on logical understanding, if you say protonation at this oxygen is expected to be more, but this should be less. And we know this is a reversible reaction. So although its contribution in the equilibrium mixture is less, but since it's reversible, so reaction can proceed in the forward direction, and that is exactly happening in this case. What do I mean? Here protonation possible, so protonation occurred, means this thing. Now what thing can happen? That this can break, and if it breaks, what? Because it said the leaving group is methanol. So in this case leaving group is methanol, and it is a neutral leaving group. So this is a neutral molecule. So if it, since it's a neutral leaving group, so its leaving tendency is higher. So point number 1. But generally we consider, I repeat the word, generally we consider that this acylium cation is unstable. Okay, I ask you one question and you write the answer. Such kind of acylium cation, you have seen one famous name reaction. What is the name of that reaction? Pause the video and write it on the comment box. Okay, now let's see. This is acylium cation is produced, and we can see that this carbon is actually a 6 electron species, means very electron deficient. So this is a 6 electron species. This is a very electron deficient. Now it needs some stabilization. How it stabilizes? It stabilizes through the conjugation of the benzene ring as well as oxygen. So if I draw one canonical form through the benzene ring contribution, because this is the unique thing, so you may consider like that. Sorry, I made mistake. This, so this could be here in this case. So what it will result? Positive charge will come this carbon, this, that is C double bond O. So in this way, through other canonical form, charge will be stabilized. Another thing, the lone pair of oxygen could also be donated in this way, and this could be another strategy for the stabilization of this intermediate. What do I mean? I am not writing the back part. That is this, and oxygen will bear the formal positive charge. So this, because of this thing, every atom is a octet filled. So 8 electron for every atom, both carbon and oxygen. Okay, by the way, you have understood. Now question, why this highly reactive intermediate, means why this highly reactive intermediate is relatively stable here? Point number 1. So first of all, the ground state energy, means this molecule is not that much stable because conjugation with the pi cloud is not possible with this carboxylic acid derivative because of out of plane energy. Point 1. But when this methyl leaves, see, it becomes a linear type. So that time the p orbital here of this sp2 carbon can come in plane with this pi nucleus. Okay, so that is the interesting point. Since it can come into the plane of this pi nucleus, so it can undergo resonance like this and stabilize the electron deficiency somewhat. So you may think the story like that: the reactant is higher energetic, product is intermediate, energy of activation is less compared to other substrate where this is expected to be somewhat this much amount of higher. Okay, so that's why it can undergo. Point number 1. So this, now this is a linear system. So in this case, water molecule can attack at this carbon, and if it attacks, and that attack should be faster because it's a carbocation, highly reactive species. And another thing, so after that removal of one proton, it resulted in the carboxylic acid. So this is the mechanism how pouring this reagent on concentrated concentrated sulfuric acid, and after that pouring water or methanol, whatever. In case of water it is given, but if you want to pour this in methanol, then instead of water, this methanol molecule will go and attack. So ultimately in this way, whether ester, or you may consider that okay, this is methanol, already it is starting was methanol, you can take ethanol. So in this way, variety of thing could be prepared. Okay, so fine. Now let's discuss another thing, that is the general ester preparation mechanism. You will understand in the next slide why I am discussing. See, in case of general ester, what happens? First protonation occurs, second nucleophile, as I told previously. After that, so actually this is a sp2 carbon. So after nucleophilic attack by this, what it produces? A sp3 carbon center, and after through the elimination again this produces again sp2 center. So what is the statement? What is the summary of this slide? Is that first protonation occurs on the carbonyl oxygen, which increases the electron deficiency at this center. Consequently, the alcohol molecule attacks here and it produces a tetrahedral sp3 intermediate which undergo water elimination and ultimately result in ester. But this thing is for common ester, general ester, okay, but not for mesitoic acid. So that's why I have given you, such that you can understand the difference between common ester preparation or general ester preparation versus mesitoic ester preparation. See, in this case, this is a mesitoic acid derivative, first dissolved in cold concentrated sulfuric acid, then poured in cold methanol, as I told just some time before. So why this happened? Because the same thing, the acylium cation is produced as the intermediate. Okay, so this carbon is electron deficient, electrophilic, so consequently this methanol molecule attacks at this carbon, and ultimately after releasing one proton it forms this ester. So thing is that in this case, so previously what was? Previously it was like sp2 to sp3 to sp2, okay, but in this case, in this mesitoic acid derivative, this is sp2 to sp again to sp2. This you remember, okay, it is interesting. So this is sp2, this carbon right now, this is sp, okay, linear, and in this case this is also sp2, okay, fine. Okay, now you may be little confused that, sir, why this is sp? So in order to remove or eliminate your confusion, you may think, you may keep this structure in your mind, means the another canonical form, this. So here see, this is a acetylene type derivative is here, so it will say, in case of acetylene hybridization is sp, so in this case you may consider that this is the sp, okay. And please keep it in mind, like common acids, simple benzoic acid also follow this path, okay. So in case of benzoic acid, sp2 to sp3 to sp2, whereas in case of mesitoic acid, this difference is only these two hydrogens. This is a dummy group, so we will not focus. Actually this group is there, but it don't have any significant direct influence on the reaction. So here hydrogen and there are 2 methyl, and what is the effect of this 2 methyl? This repulsion. So that's why the course and the mechanistic cycle completely changes, okay. Okay, so in throughout this discussion, what we have learned, that in case of mesitoic acid system, sp2 to sp to sp2 possible. In case of simple thing, but this in case of sp2 to sp3 means this tetrahedral intermediate not possible. So you can't think that hydrolysis will occur in this way, okay. Okay, so this is actually acyl oxygen cleavage, AAC1. Another thing, now why acyl? Because this bond get broken, and why one molecule, single molecule is involved in the RD step, okay. So fine, now we will discuss in some other videos about this thing detail. So this is, and second, because of, and why this unique property is introduced in this case, because of this 2 orthomethyl whose bulkness influences or forced this carbonyl group to be out of plane such that it cannot enjoy the resonance stabilization because of the through the pi cloud delocalization. Okay, so